Okay, just for a recap, I think yeah, now it's a full screen. Everyone give your role in the chat box, everyone. Okay, and also interact with me in the chat box. So interact me in the chat box. I'm seeing. Okay, so the first one is a connected load. We discussed that. Sir, what is connected load? Connected load is if you describe that all the loads basically connected or established in your home. Okay, that is connected load. It might be on, it might be off, it really doesn't matter, but the matter is that all the loads, all the fans, the power point, the lights, everything, the connections you have connected with the electricity system, that is basically the connected load. The next was the maximum demand. The maximum demand was the greatest demand of load on the power station during a given period. I discussed that in the load curve. If we go back in the load curve, the highest peak of that load curve, okay, basically gives the maximum demand. The highest peak of the load curve is the maximum demand. The next term was the demand factor. So the demand factor, so what is demand factor? Demand factor is basically the ratio of maximum demand divided by connected load. Okay, so we all know that the connected load is bigger than the maximum demand. Why? Because we do not run all the loads at the same time, even in our maximum consume time. So the connected load is always higher. The connected load is always higher than the maximum demand. So the higher value is lower and the connected value is higher. So that's why the demand factor is always less than 1. The demand factor is always less than 1. Next, we discussed average load. Average, we all know that the average is the collecting all the value and divided the number of value. Okay, so basically average load is if you consider for the daily average load. Okay, so daily average load, you can see that throughout the day you have generated all the amount of electricity. So if you combined all that, if you sum all of that and divide it by the number of hours we have in a day, then you will get the daily average load. So basically you can see that the number of units generated in a day, how many number of units you have generated throughout the day divided by 24 hours in a day. This is daily average load. For monthly average load, definitely number of unit generates in a month divided by the number of hours in a month, basically 30 into 24. Okay, 30 days into 24 hours, if you multiply, you will get the value. Similarly, yearly average load, the number of units generated in a year divided by the number of hours in a year. We know that the number of hours is 8,760. So that is average load. Next, the load factor. Load factor is nothing but just the ratio of average load and maximum demand. I said that the average load is always less than the maximum demand because there is only one value equal to the maximum demand, but the rest of the value is always less than maximum demand. That's why the load factor will be less than 1 also. Last, the diversity factor. The diversity, I discussed the difference. Okay, so the diversity factor is basically the sum of individual maximum demand divided by the maximum demand on power station. Sum of individual maximum demand, I discussed that 4% or 5% as an example, that everyone has its maximum demand in the different time. So it really doesn't happen at the same time. So if we sum all those maximum demand of that individual person, it will be definitely the bigger one. Okay, and the maximum demand on the power station is the peak, the highest peak of the load curve. So if we divide those two value, definitely the upper value is the bigger one. That's why the diversity factor is always greater than 1. Then the plant capacity factor. The plant capacity factor is basically the average demand divided by the plant capacity. Okay. And we also discussed the reserve capacity. The reserve capacity is equals to the plant capacity minus the maximum demand. Okay. So one more time, sir, what is reserve capacity? Suppose you see that in this load curve, the highest peak is 6 megawatt. So to supply these consumers, if we want to establish a power station, definitely we need to establish a power station that minimum capacity will be 6 megawatt, because if the capacity is less than 6 megawatt, it cannot provide the power at the time of 6. When the highest peak will come, the demand, when the highest demand will come, it really cannot meet up the demand. Okay, it really cannot meet up the demand at that time. So minimum capacity will be 6 megawatt, but I said that the capacity is always bigger than the minimum capacity for the future expansion. So that's why suppose we take the capacity as 8 megawatt, our maximum demand is 6 megawatt. So the amount we take a reserve for future, that is known as reserve capacity. So 8 minus 6, the plant capacity is 8, the maximum demand is 6. So the difference between the plant capacity and the maximum demand is basically the reserve capacity. I think you understand the reserve capacity. And last is plant use factor, which is quite similar to the plant capacity factor. Similar, just when you will see the number of hours or schedule, this type of words in your example mathematics, you will understand that we have to use the plant use factor, not the plant capacity factor. But both are eventually same, almost same. You see that plant use factor is basically the station outputs in kilowatt hour divided by plant capacity into hour of uses. So suppose a plant has installed capacity, or the plant capacity is 20 megawatt, and it produces an amount of output per year 7.35 into 10 to the power 6 kilowatt hour, and remain operation for 2190 hours. Okay, 2190 hours in a year. So what will be the plant use factor? Basically the 7.35 into 10 to the power 6 kilowatt hour is the station output. So we'll put that value. The plant capacity, that is 20 megawatt, we put that. An hour of use, it's already mentioned 2190. So if you put that value, it gives us 16.7%. That means you are using 16.7% capacity. You are using that capacity to produce the power. Okay, so that is quite similar with the plant capacity factor. So don't get confused when it will be this type of words, the hour, amount of hour use, amount of as per schedule, the plant is using as per schedule, scheduling. So these words will give you the clue for using the plant use factor. And one more thing was there, that is unit generated per annum. Annum means, I discussed, year, in a year. Okay, in many question, or in many example, we have to find out the amount of power we generated throughout the year. So we started from the, suppose, the load factor. Load factor equals to average load divided by maximum load, we know that. So average load will be maximum demand into load factor. So we know that the average load is the capacity in an hour. So if we multiply the amount of hours in the year with the average load, we will get the units generated in the whole year. So that's why the average load is multiplied with hours in year in this line. Next, we can just replace the average load with the maximum demand and the load factor. So that's why the equation or the formula becomes the units generated per year equals to maximum demand into load factor into 8760. That is the amount of hours in a year. Okay, if we multiply 365 into 30 into 24, we will get that hour. Okay, so yeah, almost all students have joined. So I think that this factor you have already understood. So let's go to the new slide of us today. It was just the recap, just the recap, and we'll try to go slowly. So we have no matter, nothing, to be very fast. We'll try to go slowly because this type of topics or these courses, the mathematics are very practical. So that's why we have to go. Okay, almost all students, I see more than 23 students have joined already. Please, dear students, if you don't still didn't give your role in the chat box, drop your role in the chat box. Okay, drop your role in the chat box and also your feedback, anything in the chat box. Almost all students have given, but still, if you are new here right now, just coming here, you drop your role in the chat box. Okay, so we already learned a new graph called load curve. Okay, so today we will see another curve that is known as load duration curve. That is known as load duration curve. So what is the difference? There is not so much difference. The two graphs are similar, almost similar, but a small change in a representation way. You see that in the left side, this one is the load curve, and then in the right side, this one is load duration curve. Okay, the left side, that is load curve, in the right side, that is load duration curve. So basically, you see that the load curve is basically established using the hour in the clock from 12 at night to 12 at night, the whole 24 hours. But the load duration curve is arranged in a different manner. Sir, how? At first, you need to find out the highest peak, then the next highest peak, then the next highest peak, in this descending manner. In the descending manner, the higher value will be the first, then the next higher value, then the next higher value, something like that. Okay, so you see that how to establish the load duration curve. When the load elements of the load curve are arranged in the order of descending magnitude, the curve thus obtained is called a load duration curve. So at first, see in this load curve, the highest peak is 20 megawatt. You see that the highest peak is 20 megawatt. So now we need to find out that how many hours are this 20 megawatt. You see that this highest peak, this 20 megawatt hours, started from 8 to 16. 8 to 16. 8 is basically the morning 8, and 16, when we convert this 16 into local time, we need to minus 12, and we get basically the 4. Uh, Basically the 4 or 4 p.m. So from 8 to 16, it will be total 8 hours. Okay, total 8 hours of this 20 megawatt demand. So this highest peak and the amount of hours, 8 hours, will be the first in the load duration curves. You see that this 20 megawatt at the first, and we'll start from 0. So it is totally hour basis, so 0 to 24 hour. So not about clock time, it is just hour time. We'll just count from 0 to 24 hour. So from 0 to 8 hour, total 8 hour, the capacity was 20 megawatt. The demand was 20 megawatt. Okay. The next height, if you see, it will be 15. You see that it will be 15. So 15, we need to see how many hours are for this 15 megawatt. We see that it is from 4 to 8. So that means 4 hours. 4 hours, 15 megawatt. So the next value will be the 15 megawatt. And how many hours? 4 hours. So from 8 to 12. So basically these 4 hours will be the 15 megawatt. So the next peak is 5 megawatt. You see that this is 5 megawatt, this is also 5 megawatt. So how many hours of 5 megawatt? So from 12 to 4, it is basically 4 hours. Then 16 to 24, it is basically 8 hours. So total 4 plus 8, 12 hours. So you see that from 12 to 24, this 12 hours is 5 megawatt in the load duration curve. So that's how we convert the load curve into the load duration curve. The highest peak at first, and we have to also calculate the number of hours of that highest peak, then the next highest peak and the number of hours, then the next highest peak, and that's way we put from 0 to 24 hours. So it will give us the information that suppose 20 megawatt was how much time it was 20 megawatt. So from this load duration graph, we can easily say that total 8 hours. On total 8 hours, the station has supplied 20 megawatt. So if anyone say how many hours 5 megawatt was the load, so from this load duration curve, we can definitely say that total 12 hours the load has been 5 megawatt. So basically this was the load duration curve, quite similar to the load curve, just the representation way it is a little bit different. So the 2 points, that the load duration curve gives the data, the load duration curve gives the data in a more presentable form, that we're talking about. That in other words, it readily shows the number of hours during which given load was prevailed. That I said that how many hours of 15 megawatt, how many hours of 20 megawatt, how many hours of 5 megawatt, it can give instant data. Okay. And one more thing is that the area under this load curve, the area of this load curve and the load duration curve is equal. That area is not changing at all. If we calculate the area, it is not changing at all. Both the curve has the same area, though the structure is different, but the area is exactly same. So the area under this load curve will give the, also that means the load duration curve area and the load curve area will give the units generate per day. So both the graph, if we calculate the whole area, it will give us the amount of unit we generated throughout the day. Okay, that was the load duration curve. The next slides, it is types of load. Okay, it was just introduction that different types of load. We know that load, anything is load, but there are different types of load. The domestic load we basically use in the domestic, in our household, fan, lights, this type of loads, the domestic load. So the commercial load is basically the shopping mall, the shops, the markets. Those loads are commercial loads. The industrial load basically, those loads are in the industry, the different synchronous motor, the different induction motors, okay, the lift, different loads that is available in the industry, that is industrial load. I'm not explaining so much because we just need to know that what is industrial load, what is commercial load, nothing else. The municipal load is basically load of the government. What is the street light? You see that the street light available in the Oro, both side in the street light, and also in the main city, suppose Dhaka city, the Dhaka Wasa, the power, the water distribution system, okay, the water supply system, they have the different types of pumps. So they pump using that electricity and supply those water to the the citizen of that Dhaka. So those loads, the pumps, the street light, those are the municipal load. The irrigation load, basically in the rural area, different pumping system, they try to use those pump and try to give the irrigation to their field. So those loads are basically the irrigation load. The traction load, is basically the load is used for vehicles. The electricity, suppose in the railway, in the railway, in the train, in the tram cars. The tram cars is not available in our country. It is available in the India. The tram cars basically run by electricity. There are different electric train available in the India, but and also interesting thing is that the book we're studying is basically written by Indian writer. That's why they you can see the relatable things to India. So the book written by Indian writer. That's why he has mentioned tram cars, trolley buses, because these things are available in the India. So this was just the interesting different types of loads that was you know uh, we are we can identify. So the first mathematics today we'll see very small, very easy type of mathematics to just start the chapter. And remember one thing, that this type of mathematics is very easy when you can remember all the formula properly. There is no shortcut to remember. We can understand the formula, but eventually we have to memorize that, because without memorizing or without deep understanding, we cannot write or cannot solve. So understanding the formula or equation and also memorizing at the same time will definitely facilitate your process of solving. So try to memorize, try to write frequently those type of formula. So first thing that you see, that today we'll see very small type of a generating station has a connected load of 43 megawatt, basically connected load. At first you will read the question very carefully. The connected load is 43 megawatt and a maximum demand of 20 megawatt. Okay, and units generated is 61.5 10 to the power 6 per annum. So we have to find out two things. One is calculate the average load, calculate the demand factor and also the load factor. So at first we need to write the two equation, then we will see what are missing, what are given. So to find out the demand factor, you see the demand factor, to find out the demand factor is equals to, we all know that the maximum demand by connected load, if we all know. So what are the things given? You see that the connected load is given 43 megawatt and also the maximum demand is also given 20 megawatt. So it's a very easy, just like easy cake. You put this to a value, you get that it is that 0.465. So as we all know that the demand factor is less than 1, we can see that the value is less than 1.465. The next thing is that we need to find out the load factor. So we always need to write the equation first, then we will see what are given and what are missing. The missing terms we will find out anyway, and the given terms will be given. So the load factor is basically the average demand by the maximum demand. So you see that the average demand by the maximum demand is given. We can see that the maximum demand is given, which is 20 megawatt. So the average demand is not given. So how to find out the average demand? So we know that one more information is given, that is units generated per annum. That means per year. In a year, this amount of electricity, say 61.5 into 10 to the power 6. Okay, this unit. So we know that, sir, this is generated in a whole year. So if we somehow divide the amount of hours in a whole year the amount of hours in a whole year, at that time we will get the average. So that's why the average demand will be units generated per year divided by hours in a year. Okay, so divided by hours in a year. So 61.5 into 10 to the power 6 divided by hours in a year. Hours in a year means in one, that will be 8,760. That is the hours in a year, total hour in a year. Okay, so finally if we divide, we'll get the 7020 kilowatt. That is average demand. That is average demand per hour. So if we divide the average demand by maximum demand, we'll get the load factor. So now the average demand is 7,020 and the maximum demand, we know that already given 20 megawatt. So we'll just convert this 20 megawatt into kilowatt. 20 into mega means 10 to the power 3. So 20 into 10 to the power 3, we divide, we'll get that 0.351, basically 35.1%. That's how we just solve this kind of small mathematics, but definitely we need to know the formula very well. So heading to the next one, the question is given: a 100 megawatt power station delivers 100 megawatt for 2 hours, 50 megawatt for 6 hours, and it is shut down for rest of the each day. Okay, so it is also shut down for maintenance for 45 days each year. So calculates its annual load factor. Annual load factor we have to calculate. So as it is annual load factor, we have to calculate. If you know the properly, the equation was units generated per year equals to maximum demand into load factor into hours in a, into hours of use, basically. So at first we will see that the information is given for one day, that a 100 megawatt power station delivers 100 megawatt for 2 hours and 50 megawatt for 6 hours. So if we calculate for one day the generation, so basically it is for 2 plus 6, total 8 hours. Total 8 hours it been operational throughout the 24 hours. So you see that in one day 100 megawatt for 2 hours, so 100 into 20 plus 50 into 6 hours, so this is 400. So energy supplied for each day, every day it's supplied 100 into 2 hours plus 50 into 6 hours, so total 500 megawatt hour it's supplied for one day. And interestingly, one more information is given. The power station is shut down for maintenance for 45 days. So throughout the year, 45 days the whole power station is shut down. So how much active day? The active day is 365 minus 45 days. It will be 320 days in a year. Okay, 320 days in a year are the active days. So this 500 megawatt hour is for one day. So now we will calculate for the 320 days in an hour, in a year. So the energy supplied or the energy generated, basically the energy generated and energy supplied is the same, because there is no way for reserving. In AC supply or in AC power we cannot reserve. The DC supply we can reserve. So the energy supplied or the energy generated are the same. So that's why 500 megawatt into 320 days, if we combine, it will be 1,60,000 megawatt hour. Okay, 160,000 megawatt hour. This is the energy generated throughout the day. Throughout the year. So if we need to find out the load factor, we know the equation is energy or unit generates in a year equals to maximum demand into load factor into the hours of use. Basically, if use total 1 year, it will be 8,760. But in this case, the working hour is not that, because 45 days have been stopped. So if we just rephrase that equation, the annual load factor will be the megawatt or supplied per annum means per year, divided by the maximum demand in megawatt into working hours. You may get confused. Let me see that equation one more time so you will get not confused what I'm talking about. You see that that is the units generated per annum equals to average load. Basically, the next equation, the maximum demand into load factor into 8760 for 1 year. So if we just take this load factor this side and these two value on the other side, it will be units generated divided by the maximum demand into 8760 if it is running throughout the whole year. Okay, so that was this equation has been modified here. Okay, so you see that the don't confuse, that's our there was 8,760. Yes, if the power station have been operated for throughout the whole year, then it was true. But you see that here the 45 days have been stopped. That's why it is the working hour will be 320 days into 24. Okay, so when we'll put that value, we'll get the annual load factor is 20.8%. Definitely multiply with 100. So that's how we will calculate. And you see that the equation, the formula can help us a very big time if you remember properly. So there is no complexity. It's just the knowing the equations properly, identify the value properly, and just put the value in the right place, and it will give you the answer. Okay. A little bit a bigger one, but not the very tougher one. Very easiest mathematics. Just at first you try to read the question. It is the generating station has a maximum demand of 25 megawatt. So basically maximum demand is 25 megawatt. Load factor 60%. Okay, load factor is given 60%. Plant capacity factor is 50%, and also plant use factor 72%. So all the factors, almost 3 factors have been given. So we have 3 questions one by one. The first one is the reserve capacity. We need to find out the reserve capacity. If you remember properly, so what was reserve capacity? The reserve capacity was the plant capacity minus maximum demand. The plant capacity minus maximum demand. You see that the plant capacity minus maximum demand. So the maximum demand is given 25 megawatt. The maximum demand is given 25 megawatt. So we need to find out the plant capacity. So the plant capacity, if you remember, which formula is related to the plant capacity? If you remember properly, the plant capacity factor formula, this formula, the plant capacity factor is equals to average demand by plant capacity. This formula will give us the plant capacity, because the plant capacity factor is given in the example, in the question, 50%. The plant capacity factor is given 50%, but the average demand is not given. The average demand is not given. So if we want to find out the plant capacity, we need to find out the average demand at first. So going back side, at first writing the equation, and what term is missing, we need to find that term. So we see that the average demand is missing here. So for that, how to find out the average demand? You see that load factor is given, and also the maximum demand is given. So if we go for the load factor formula, the average demand equals to maximum demand. So maximum demand is given, also load factor is given. So we put these two value, we'll get the average demand from this equation. You see that just knowing the formula properly will give you the exact value. So average demand will be the 25 into 0.6 equals to 15 megawatt. And I already said that the average demand will be always less than maximum demand. You see that the average demand is 15 megawatt and the maximum demand is 25 megawatt. So we got the average demand value. We put this average demand and the plant capacity factor is 50%, that is 0.5. We get that the plant capacity is 30 megawatt. Clear? First, we need to find out reserve capacity. Reserve capacity is equals to plant capacity minus maximum demand. The maximum demand is given, so we need to find out plant capacity. The plant capacity is related to the plant capacity factor. So when we go for the equation, we see that the average demand is missing. We find out the average demand from the load factor and the maximum demand. We put that average demand. We got that plant capacity factor and average demand. So now we can get the value of plant capacity, that is 30 megawatts. So that is the process. That is the process, knowing the equation properly and just finding the exact value. So now the reserve capacity, the plant capacity minus the maximum demand. The plant capacity is 30 megawatt and the maximum demand is 25 megawatt. So basically the reserve capacity is 5 megawatt. Okay. The next question is the daily energy produced. The daily energy produced. You see that we have already find out the average demand. If we multiply the average demand in the number of hours of a daily, we'll get the daily energy produced. Average demand or average load is the produced for 1 hour. Okay, produced for 1 hour. So for daily energy produced, if we multiply that average demand with the 24, that means hours in a day, we'll get the daily energy produced. Okay, daily energy produced. So you see that 15 into 24 by 360 megawatt hour. So in our equation, in our example, only one factor is missing, that is use factor, that is 72%. So last, the maximum energy that could have been produced daily if the plant was running as per schedule. You see that the as per schedule, the hours, this kind of clue for use factor when the fully loaded. So we know that, sir, what is use factor? Use factor means how much capacity we have used. How much capacity we have used. Suppose I have the capacity of pulling 20 kg, but right now I am pulling 5 kg. Okay, I'm using 5 kg. So the ratio will be the use factor. So that's why you know that the ratio, the maximum energy can be produced will be actual energy produced divided by the plant use factor. If you just cross multiply, it will be given as a much clear, you know, idea. The plant use factor will be the actual energy produced divided by maximum energy produced. Okay, just then the cross multiplied, it has been cross multiplied. So the maximum energy produced, that is asking in the question number 3, will be actual energy produced in a day divided by the plant use factor. So basically actual energy produced 360 megawatt divided by the plant use factor. Okay, the plant use factor. So the value is 360 divided by the 0.72, we'll get the 500 megawatt per day. Basically 500 megawatt we can produce. Okay, so that is the maximum energy produced we can, if we go for the maximum. It can be you know, find out one more in the similar way, that maximum energy produced, that can, you are using your maximum capacity, you are using your maximum capacity in every hour. That means you have in our question 25 megawatt. If we multiply 25 with 24, that means, you know, in a day 24 hours, it will also get the, you know, the 500 megawatt hour per day. Okay, so that's how we'll solve this kind of mathematics. And last but not the least, it will be very easy for you, so we don't need to very much discuss, just to go away. that a power station has a maximum demand of 15,000 kilowatt. The annual load factor is 50%. The plant capacity factor is 40%. So determine the reserve capacity. As I said, the reserve capacity is the plant capacity minus maximum demand. The maximum demand is given, so we need to find out the plant capacity. We need to find out the plant capacity factor. So the plant capacity factor as the annual load factor is given. So the plant capacity factor, we all know that the plant average demand by plant capacity, average demand by plant capacity. So you see a small change, units generates per annum divided by hours in a year. So if you divide that units generates per annum, the total unit generated in a year divided by total hours in a year, you will get the average demand. Okay, so basically the equation is not changing at all. The equation is not changing at all, because if you divide this units generated per annum divided by the hours in a year, okay, you will get the average demand. So hours in a year we all know, and units generated per year, if we want to find out, we know the equation, the maximum demand into load factor into the hours in a year. So you see that maximum demand is given 15,000.5, and this hours we get the value. You see that this 8,760 is multiplying here, and here we are dividing. So basically we are doing nothing. We are using this factor one. First time we are multiplying, and then second time we are dividing. So if you don't use this way and use that the plant capacity factor is the average demand by plant capacity, at that time you need to find out average demand. The load factor is given 50%. We know that the load factor equals to average demand by maximum demand. Okay, so at that way you can also get the same answer. So there is no change, don't be frightened, no change. So using that value, the plant capacity, we need to find out the plant capacity. The plant capacity factor is 40%, so that means 0.4. We get the plant capacity. We just put the plant capacity minus the maximum demand. We get the, okay, we get the reserve capacity. So there is no change. There is no change. The question, the solve is done in a different way, just for making us in a more compatible with the equations, different equations. So if you don't want to solve this way, you can use the plant capacity equation, factor equation, something like that. That plant capacity factor equals to average demand by plant capacity. So same way in the 3.4, the same way it has been shown, it can be solved. The 3.6 also exact same way. If you solve this way, it is also same. If you solve this way, it is also same. So there is no such difference, just a different representation, just making us more compatible. So that was the today's lecture. We have just started the mathematics. The next mathematics will be much more tougher, much more complex. So today we have just starting the glimpse of mathematics, and also tried to explain the load duration curve. The main thing was the load duration curve, and the main gist was that both the curve was same. Okay, both the curve is quite same, just a small representation. So dear students, that was the today's class. If you have any question, you can ask in the chat box. Chat box, and also also you can, if you are new here, drop your role in the chat box. Okay, there are some questions are coming. Sir, say Muhammad say that, sir, say again the curve again. Okay, he's asking that, sir, what is load duration curve?